Hi folks, this is the Seek Geek. Got this YouTube channel where I upload some of my projects that I've done over time. I've got this one interesting one. I got around to looking at it yesterday. I did this a while ago. Constant improvements as time goes by. Last improvement I made to this was, I think, about 6 months ago. Anyway, I thought I'd just upload this. It's an event controller based on the Arduino processing system. It uses the Atmel LKM1638 processor. Standard stuff you can buy on eBay. All the boards, the LED arrays with buttons and everything, comes out of China, I believe. Anyway, I put this together to create an event controller. Now what on earth is the event controller? Well, anyway, you just define some variables, and then if you have conditions less than, equal to, greater than, equal to, all the good stuff, and based on that you go down tables and you can set tasks to run. And it also utilizes keyed button tables, so instead of just processing ad hoc, you set up tables for the button presses, and then you can just shoot off to wherever you want to, whatever task you want to fire up. Anyway, don't want to bore you, so let's try and get through this quickly. I'm going to fire this thing up. Better tell you what it does. This event controller has been programmed to become a audio power amplifier tester. Essentially, there's 4 channels. It can handle 6, but there wasn't enough buttons. The tester is connected to a load, 8 ohms, switchable 8 ohms, 4 ohms, 2 ohms, and 1 ohm. The power amplifier is obviously connected to the load, and obviously you put audio signal through. It heats up the load. And then of course this device, this event controller, is looking at the temperature, and based on temperature you set warning levels and you carry on to critical levels, and based on reaching a critical level you disconnect the channels, and that's what I'm going to demonstrate today. So let's fire this guy up anyway. Here we go. Okay, I'm going to back out and just show you all the channels. Okay, I've got 4 channels wired up here, and they're all independent. Just want to add one thing from a programming point of view. I'm from the old school, the old C school. I've got an acronym TMP, Type Defs, Macros and Pointers, which is the way I was taught C, and especially for real-time work. And this is heavily based on macros as opposed to inline code, and it's kind of interesting. I can accomplish quite a bit. Got full synchronization on flashing. You'll see that in the demo. Now we're starting off in real-time mode here. The 2 digits on the left hand side are temperature, controlled by these sensor guys here. Standard stuff, just input, do a little bit of calculation, and then display the digits. So in the garage it's approximately 25 degrees, 25, 24. Okay, the middle digit here is designating ohmage, which is what the load would be set to. You can do that manually here on the buttons. This would be 8 ohms, it hasn't shifted. Okay, this would be 4 ohms. It would display 4 ohms, but because we haven't got this connected to a live load, it's not understanding what's going on, so it's flashing. We're requesting 4 ohms, but it doesn't know that, so it flashes. This is 2 ohm setting. The red light comes on because just to alert the fact that 2 ohms you could get quite a bit of power going through the load, ultimately temperature. And you got a 1 ohm setting here. Excuse me. And the 1 ohm would be if the load was connected, it would switch to 1 ohm, and then of course you get the 1 there without the flashing. So let's get rid of this flashing. Let's go back to 8 ohm settings. Okay, now you can do this independently to any channel, of course, totally independent of just to let you know, and you can see that the flashing is quite in sync. so you don't get crazy flashing all over the place. Right, let's reset all this guy. This is the master reset up here, so let's just reset. Okay, the 2 digits on the right hand side are RMS power. It's a bit meaningless right now because this is real-time mode and I've got a couple of potentiometers here centered, so voltage goes across, and if I move the potentiometer all the way to the left, as you can see, channel 1 will get most of the voltage, and then if I move it completely to the right, channel 2, just to show you the real-time setup here. Okay, let's get that back in the middle. Okay, let's do the third. Hey guys, I'm back. I don't know what happened there. The camera just stopped on me, so I just pick up where I was. So we're on the second pot. Let's fire this guy up again. Okay, as you can see, I'm going to the other side, and then channel 4 gets most of the voltage. Let's just zero back up in the middle. Okay, around about there. That's good enough. Okay, next feature I want to show you is precision. I've got an auto precision system going on here where you can change the precision. Right now it's 0 precision. If you press this, you get 1 level of precision. If you press it twice, you get auto, which means it tries to fill up every digit that's vacant. As you can see, temperature had 1 digit vacant. So the temperature is reading at 31.4 on channel 1. The RMS power is reading at 82.85. Let's reset this back to 0 precision. Just wanted to just show you that feature. That's quite interesting. Okay, let's fire up the torch now to show you a little real-time temperature controlling. So we're going to just heat up this channel 1. As you can see, it's coming up a little bit. 45, 44, not enough. Okay, let's do a little bit more. Okay, 61, 62, 60, no good. Okay, the threshold is 65. It's going to start flashing around 65. So we'll carry on doing that a little bit more. Let's see what we can get. Okay, let's hope it goes beyond 65. If it does, no, it didn't. Okay, we'll try one more time. Okay, there we go. Right, it's flashing right now. If it carries on to 85, it's going to disconnect the channel. But if it doesn't do that, here's no big deal. They are all independent. I'll show you. I'll just heat this guy up in channel 4, and that should be start to rise as well. There it goes, 47, 55, 54. Okay, good stuff. Right, let's move on a little bit quickly, and let's go to simulation mode. But before I do that, let me just show you dimmer function. There you go. You can go right down to dimmer function there. This is maximum. We'll leave it at that. Let's go to simulation mode. Okay, this is simulation mode where the actual controller is setting everything. I've skewed everything just to show you what's going on here. Channel 1 is 1 degree higher than channel 2, is 1 degree higher than channel 3, is 1 degree higher than channel 4. So it's going to show you the flashing, synchronization, and the disconnection of the channels. It's quite interesting actually. Okay, when we approach on channel 565, it starts getting nervous. Channel 2 is getting nervous now. Channel 3 is getting nervous. Channel 4 is getting nervous. Okay, continue rising. So the power amplifier is pushing a lot of power into the load. Load temperature is rising. Okay, channel 1's approaching 85. You'll see what happens. There you go. It's unloaded. It's disconnected, that channel. Channel 2's unloaded, channel 3's unloaded, channel 4's got unloaded. But you see, because you unload, obviously there's no power going to the load, which means the temperature will start dropping, and the minute it comes back below 65, it's stabilized out, and there you go. Now, one other feature I got here is a scroll function, which can be set independently. We just happen to be looking at RMS power here, then there's peak power, which is almost double. And then you got the RMS voltage here. Now you can set this independently in all channels. You don't have to have the same variable. I'm not sure why anyone would do that, but there you go. I've got a master scroll switch here which resets everything and then starts scrolling all channels to show you the different variables in sequence. Quite interesting. And there you go. I hope that's an interesting setup here, just to demonstrate what's capable with these little microcontroller guys. The next project is going to be world clocks. I'm going to put a project together with the same setup, just configure the software to display I don't know, 4 major cities in the world and have a decent world time clock. I don't use any interrupts on this project. It's all polling, and all the synchronization flashing is done. I made a mistake earlier. I said macros opposed to inline code is actually macros opposed to functions. Functions will give you, obviously, use up less space, but macros will produce inline code. There's trade-offs, of course, but you can do a lot more interesting things with macros. Okay, there you have it. Hope it wasn't too boring. It's a Seek Geek signing off. Take care now.